Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to go over a practice problem involving dimensional analysis where we're going to use measurements and conversion factors. And so the problem on the board says that we have 1 liter is equal to 1 decimeter. That's true by definition. So that means that we have just defined it to be the case that 1 liter is going to be equal to 1 decimeter. I think I said deciliter last time. I meant decimeter. And then it also tells us that we know that 1 inch is equal to 2.54 centimeters. Is that exactly? And they want us to express the volume of 1 liter in cubic inches. So the first thing I tell my students all the time is when you're dealing with word problems, pull out the conversion factors, pull out the relationships that they give you and write them as equalities, because that's what we're going to be using as conversion factors. So the first one they give us is 1 liter is equal to 1 decimeter. So let's write that as a conversion factor or as an equality that we will later use as a conversion factor. So 1 liter is equal to 1 decimeter. Okay, so that's 1. They also gave us that 1 inch is equal to 2.54 centimeters. That's exact. This is the only time that you have an English unit exactly equal to a metric unit. Any other time that I know of, if you know of another example where this is the case, let me know. But any other time you have an English unit matched up or equated with a metric unit, that's going to be an inexact relationship. It's going to be a measurement. But in this case, it's exact. So we're going to write that down as another equality that they gave us. So 1 inch is equal to 2.54 centimeters. And that's the only relationships they have given us in the problem. We may need to use other relationships not given in the problem, but are kind of universally known, at least here in the United States and elsewhere. So now the next thing you want to do is figure out where you're going to begin and where you're going to end. And that is where the question is. So you look for the question. If there's a question, 99.9% of the time, it's going to tell you where to begin and where to end. And the beginning of the question is what you're looking for. The beginning of the question tells you the end of the problem. The beginning of the question tells you the end of the problem. So where's the question? They don't have a question. So they're telling us, though, express the volume. So we're going to express the volume. What volume? 1 liter in cubic inches. If I was going to ask that in a question, the question would be, how many cubic inches would there be in 1 liter? So that would be the question. How many inches, cubic inches, or inches cubed, would be in 1 liter? So how many cubic inches? Cubic inches is what they're wanting. So we want cubic inches. So that's going to be our end of the problem. Cubic inches whoops, I put centimeters. What am I doing? Inches. I want cubic inches or inches cubed. All right, so that's the end of our problem. And so, what's the beginning? The beginning is usually going to be something that gave us in the question or in the problem itself. Usually, it's going to be something that it has a standalone unit. It's not going to be a mixture of units. It's not going to be one thing over another. Usually, it's just a standalone unit. It's only got one unit after it. It's not going to be like grams per centimeter cubed. It's not going to be like meters per second. It's just going to be something. And that is what we have here with 1 liter. So they want to know how many cubic inches is equal to 1 liter of whatever substance we have. So 1 liter is what we're going to begin with. So we have 1 liter. So we're going to begin with 1 liter and we want to end with inches cubed. We've got our conversion factors. So let's get into this. So the first thing you want to do is start here. Now, there are different ways of doing this to set up your conversion factors. Some people like to use the line with the kind of table format where you put everything in here. I don't usually use that, but it's a great idea if that works for you. I just use the multiplying with fractions or ratios. So that's usually how I set it up. Um, so let me go ahead and erase this. Okay, so I take what they give me and I always put it over 1. So I have 1 liter and I put it over 1. Now notice there is no unit here. It's just over 1. I'm creating a ratio or a fraction because I'm going to be multiplying by conversion factors, and conversion factors are fractions or ratios of one unit to another. So now I know where I'm beginning, I know where I end. In the middle here is multiplying by conversion factors. So all I'm doing is I'm multiplying by conversion factors until I get the unit I want on top. So I take my 1 liter over 1. I'm going to start. I put a multiplying sign and a line, and I'm going to create my fraction, my ratio here. Okay, so whatever I have on top here, I have to be on the bottom. It has to be on the bottom. And what I'm talking about is not the number, but the unit. So the number, you don't have to put the same number down, but it should be the same unit. So then I need liters. I need to convert liters to something. I need to get rid of liters. So I go to here. I have 1 liter is equal to 1 decimeter. And that should be cubed. That was my bad. So this should be decimeter cubed. Right? So cubed. My bad. So this should be decimeter cubed. That should be decimeter cubed. So 1 liter is equal to 1 decimeter cubed. And so I have this relationship here. I have this equality. So all I'm going to do is I'm going to put one side on another, either on the bottom, and one side is going to be on top. Since I have liters here, this should be on the bottom. So notice I have 1 liter is equal to 1 decimeter cubed. So the 1 liter in this case goes on the bottom. It happens to be 1 liter here. It didn't have to be, but in this case we have 1 liter. So the 1 liter is going to go on the bottom because I need to cancel out liters on top. So 1 liter goes on the bottom. So I have 1 liter. And the 1 decimeter cubed goes on top. So 1 decimeter cubed. So that means liters is going to cancel out. Now I have decimeters cubed. So now I have decimeters cubed. Now what do I need? I still need inches cubed. So I need to get the inches somehow. I have 1 inch is equal to 2.54 centimeters, but I don't have centimeters. I have decimeters. So if I could convert this to centimeters, then I can use this. So I'm going to have to use my metric system and my metric prefixes. So I need to know what the prefixes are. Now, if I knew the relationship directly between decimeters and centimeters, I could use that. I don't know that off the top of my head. Not many people do. I'm sure you could figure it out. I'm not going to take the time to do that. It's a lot easier for me to just go through the base unit as a middleman, right? So I'm going to convert decimeters to meters, and then I can use meters to convert the centimeters. It's a 2-step process, and so we'll do that. So to convert decimeter to meter, I need my conversion factor. We'll do it here. So the way I set this up, in order to not make a mistake, the way I set up my metric relationship between my metric units is I always set up the equality, and I have my units. So I put my unit here. Maybe I want meters and decimeters. So I'll put meter here, and I'll put decimeter here. And so now I need to put the numbers in for each of these. So the way I do it is I always put the 1 with the prefix, not with the base unit. I put it with the prefix. So I'm going to put a 1 here. So 1 goes there. And then I need to know what the prefix multiplier is for deci, right? This is important. So decimeter, if you can't remember remember decimate. If you decimate a city, decimate literally means you kill off 1/10 of the population. So if a city or country is decimated, you've killed off 10% or 1/10 of the country. So that's 1 over 10 or 10 to the negative 1. So I'm going to take, so deci is 10 to the negative 1. So I'm going to put 10 to the negative 1 on this side. So the base unit always gets the prefix multiplier. The prefix unit gets the 1. And that way I know that this is true. This equality is true. I'm not going to make a mistake. And so that's one relationship I'm going to use. Now I can use the centimeter and meter relationship. So I do the exact same thing. So I'm going to put meter here, and I'm going to put centimeter here. And so I put the 1 with the prefix unit. And then centi, I need to know what the relationship or the prefix multiplier for centi is, and that's 1/100th of the of the measurement that you're using. So in this case, it's a meter, so 1/100th of a meter, so 1 over 100, or 10 to the negative 2. So I'm going to put 10 to the negative 2 there. So 1 centimeter is 10 to the negative 2 meters. So now I have my two relationships there. Now I can use those to convert from decimeters cubed to centimeters cubed. So what I'm going to do now is I'm going to set up another conversion factor. So I have decimeters cubed on the bottom. I need decimeters cubed on, I'm sorry, I have decimeters cubed on the top. I need decimeters cubed on the bottom. Now notice I have a relation between decimeters and meters, not decimeters cubed in meters. So I can set it up that way to start. So since I have decimeters cubed on the top, I'm going to put decimeters on the bottom. So 1 decimeter, so this side is going to go on the bottom, 1 decimeter. And then the other side, 10 to the negative 1 meters, goes on top. So 10 to the negative 1 meters. Okay, great. So we're on our way. Now notice that this dm, decimeter, is only going to cancel out with one of these. So it's like if I had x on the bottom and I had x cubed on top, right? So this would be the same as x times x times x over x. So 1x would cancel out with one of those x's. I would have still x times x on the top here. So same thing here. I have 1 dm here. This dm or decimeter is only going to cancel out with these 3 decimeters on the top. So that's like having decimeter times decimeter times decimeter over decimeter. So that's going to cancel out one of those. So I need to do one of two things. Either you can multiply by the same conversion factor 3 times, right? So I could do this. I could just put another one there. 1 decimeter over 10 to the negative 1 meters. So then that one would cancel out with one of those. This one would cancel out with another one of those. And then I could do a third one, right? 1 decimeter over 10 to the negative 1 meters. And then these 3 would cancel out with all of these 3 here. And then the units would be canceled out. And I'd have meters times meters times meters, which is the same thing as meters cubed. So I could go from decimeters cubed to meters cubed by taking the conversion factor that I'm using and multiply it 3 times. That'll take a lot of space, but it would work. Um, Another way you could do it is, since this conversion factor is multiplied 3 times, that'd be like taking x times x times x. That'd be x cubed. So why not just cube the conversion factor? So you save yourself some space in the process. So let's do it that way. So I'm going to then erase these two. And so I'm just going to put a cubed around it. So then this is cubed, the bottom is cubed, and the top is cubed. So this cubed, right? That's going to be cubed. And then that's cubed as well. So decimeters cubed cancels out with decimeters cubed. And now I have meters cubed, and I have 10 to the negative 1 cubed. So when I'm doing my calculation later at the end, I want to make sure that I cube this or multiply it 3 times when I'm doing my calculation. Okay, so now we have meters cubed. And so my next step is to go from meters cubed to centimeters cubed. And now I'm going to use this relationship here. So since I have meters cubed on top, I want meters on the bottom. So here I have 10 to the negative 2 meters. So I'm going to put 10 to the negative 2 meters on the bottom, and then 1 centimeter on top. So now I have 1 centimeter on top. And I have meters cubed here. I only have meters here. I want meters cubed. So again, either you can multiply by this conversion factor 3 times, or you can just cube the conversion factor. So again, if that means that both of these are cubed, so I'm cubing the bottom, which means that this is going to be cubed, right? I have meters cubed and I have centimeters cubed, right? 1 cubed is 1, so that doesn't do anything. Now I have centimeters cubed on the top. Meters cubed cancels out with meters cubed. And now I have centimeters cubed. Now I can use that one. So my last conversion factor, since I have centimeters cubed here, I'm going to have centimeters on the bottom. So 2.54 centimeters. And my 1 inch on the top. 1 inch on the top. And again, since I have centimeters cubed here, I only have centimeters here. I want inches cubed. So I'm going to take this and cube it. And once again, I'll get my centimeters cubed and my inches cubed. Now, you got to remember that this is cubed, that 2.54 is cubed. So when I do my calculation, I need to make sure that I divide that 3 times. So now I have my centimeters cubed cancels out with the centimeters cubed there. And so now I have inches cubed, right? So this is inches cubed in there. And so now I have inches cubed, which is what the problem is asking for. So now I know I can stop with the conversion factors. I am done. So at this point, it's just multiplying by using your calculator to figure out the answer. So let's go ahead and figure that out. So I'm going to get my calculator. Okay, so, and what I'm going to do is I'm going to multiply by everything on the top, and I'm going to divide by everything on the bottom. So I'm just going to multiply, and then divide. If it's a 1, I skip it because it's not going to do anything. So this is a 1, this is a 1. Okay, 10 to the negative 1. So that means it's cubed. So remember that cube goes to 10 to the negative 1. So I'm going to cube that. So I got 10 to the negative 1. Okay, oops, hold on a second. So 10 to the negative 1. Okay. So I cube that, and then I'm going to multiply that by the next one. That's a 1, so I can skip that. That's a 1, I can skip that. Okay, so I've got the top already done. Now I'm going to divide by what's on the bottom. And again, I'm going to skip the 1s. So 1, skip that 1, 1, skip that 1. Here I have 10 to the negative 2 cubed. So now I'm going to divide by 10 to the negative 2. Okay, and then I'm going to divide by 2.54 cubed as well. So divided by 2.54 cubed equals, okay, and for my answer, I get, let's see here, 61, 02 point, and then there's some 373744 dot dot dot. Okay, let's double check our answer, make sure that's correct, make sure I didn't make any mistakes. Because I think that's a mistake. So let's see. So 1 to the negative 10 to the negative 1. Okay, so cubed. And then I'm going to divide that by 10 to the negative 2. So let's see here. So divide by 10 to the negative 2. Cubed. And then I'm going to divide that by 2.54 cubed equals, yeah, that was a mistake on my part last time. So watch out for calculator mistakes. It can be easy to make. All right, so I have 61. I was off by a factor of 100. So 61.0237023744 dot dot dot. Now, and this should be inches cubed for your units. Don't ever forget units. Now here, the last thing you want to make sure you do is figure out the significant figures. So the number of sig figs in this should match the number of sig figs you're using in your multiplication and division. Remember, the rule for sig figs is the answer when you're multiplying and dividing, your answer should have the same number of significant figures as the least number of sig figs you used. Now, anything that is exact is ignored, because if you have an exact relationship, then that has an infinite number of significant figures, so it's definitely not going to be the least. So here, 1 decimeter cubed is equal to 1 deciliter. That's exact. That's true by definition. And you can tell that by the fact that we've got metric units here. 1 decimeter cubed is equal to 10 to the negative 1 meters. That's true by definition, so that's exact. 1 centimeter cubed. 1 centimeter cubed is equal to the 10 to the negative 2 cubed meters cubed. So that's true by definition because we are using this relationship with this, which is exact. And we are told that the 1 inch is equal to 2.54 centimeters. So that relationship is exact. So all of this is exact. So that means that this number is exact. So the number of digits keeps going on. So that's why I have the dot, dot, dot there. So that would be your final answer. So I hope this was helpful. If you like this video, if you like the video, share it with others. Please hit the like button over there. If you like the channel, please subscribe to the channel so that way you can get more videos. Put a comment in the comment section. Let me know what you think and if you have any other questions. Thanks for joining me and have a great day.